Hello friends, in today's question, a wooden block floating in a bucket of water has 4 by 5 of its volume submerged. When certain amount of oil is poured into the bucket, it is found that the block is just under the oil surface with half of its volume under the water and half in the oil. The density of oil relative to the water is. So here we have two conditions. In the first condition, there is a bucket and this bucket only has the water. And in this case, it is given that a wooden block has a volume which is 4/5 of its volume is submerged in this water. Okay, so let us draw something like this. Okay, so 4/5 of the volume is submerged in the water. So this is only water. So this is our initial condition. We can say this is our initial condition. And in the second part, we are given that oil is added in the water, and now the half of the block is in the water and half is in the oil. So let us see, this is our now water and this is our oil, and the block is just under the surface of the oil. Okay. So you can say this is our block and we have oil and this is our water. So let us call this as final condition. So in the first case, the buoyant force will be only because of the water, and in the second case, the buoyant force will be the summation of the oil buoyant force as well as buoyant force provided by the water. In the first case, it is only going to balance the weight is only, you can say, the weight will be only balanced by the water. In the second case, it will be balanced by the oil and water. So this is the basic premise of the solution. So let us discuss first of all the initial condition. So in initial condition, we have block is floating in the water. Block is floating in water. So it is given that only the 4/5 volume of the block is submerged when it is in floating in water. So therefore you can say that the wooden block is floating in water with 4/5 volume submerged. Therefore, the buoyant force will be equal to the water displaced by the submerged volume, and submerged volume is 4/5 of the volume. And if we take V as the volume of the block, so we can say only 4/5 times V will be submerged, and the buoyant force that will be responsible will be only dependent upon the 4/5 times the volume, that is V. So we can say from here, therefore the buoyant force FP will be equal to amount of water displaced by the submerged volume. Amount of water displaced by the submerged volume. So buoyant force is given as Fp. We have written it Fp rather. So we can Fp is equal to density of water multiplied by 4/5 times volume, where V is the volume of the block, and multiply by G. You can see from here, or rather write it from here, that rho W is the density of water V is volume of the block and G is our acceleration due to gravity. And this buoyant force is going to balance the weight of the block. This buoyant force will balance the weight of the block. Let us suppose that is given as WB, and WB will be equal to mg, and that will be equal to density of the block multiplied by volume multiplied by g. Okay. So where this rho b is density of the block. V we already written, that is the volume of the block. So we can modify the equation, or rather we can say that Fb, that the buoyant force, will be equal to weight of the block. So this gives us that rho W 4/5 G is equal to density of the block multiplied by volume multiplied by G. So here Vg cancels out. So we get that density of the block will be equal to 4/5 times density of the water. Now we come to the final condition when block is floating both in water and volume. Final condition, block is floating in water and oil, and it is given that it is half submerged in oil and half submerged in water. So you can see when oil is added, block is half submerged in oil and half in water. Therefore, the total buoyant force will be equal to the water and the oil, and both this combination of buoyant forces is going to balance the weight of the block. You can say therefore the total buoyant force is due to water and oil, which will balance the weight of the block. So we can write it that weight of the block is equal to buoyant force due to water force due to water plus buoyant force due to oil, and it is given half submerged in water and half submerged in oil. So therefore we can say density of the weight of the block is rho bv multiplied by g. This is density of water multiplied by half of the volume g plus rho o, and this is half v multiplied by g, where this rho o is density of the oil. Rho o is density of oil. So this vg cancels out, and we also know, you can say found out that rho b is equal to 4 upon 5 rho w. So we can say density of the block is 4 by 5 times density of the water. So we are going to use this relation, so we can put it here. We get this as 4 by 5 rho w is equal to, we have this rho w 2 plus, and here we have rho naught divided by 2. So now it is simple. So you can say adjustment of the equation. So we get half rho naught will be equal to half rho w minus 4 by 5 rho w. So this is 1 by 2 minus 4 by 5 rho w, and we get this as half rho naught. This becomes 10, and this is I wrote in, sorry, minus and plus, my mistake. So this becomes as our 3 rho w, and 2 cancel this 5, so we get rho naught upon rho w is equal to 3 upon 5, and which is approximately equal to 0.6. And we are supposed to find out a relative density of oil with water. Okay, so this is relative density of oil with water. You can say therefore density of oil relative to water is equal to 0.6, and the options that are available to us, option number A is the correct option. Option A is correct. So this completes the question. Thank you.